You know that an equation is called an identity when it is true for all values of the variables involved. Similarly, an equation involving trigonometric ratios of an angle is called a trigonometric identity if it is true for all values of the angle or angles involved. Hello and welcome to MATHSPEDIA, a math learning hub, and I am Meena, your math guide. As you know that we have already started chapter number 8, Introduction to Trigonometry of class 10th, and in the previous class we have learnt trigonometric ratios of the acute angles in a right angle triangle. If you have not watched that video yet, you can do so by clicking on the link given in the description box. So today we will learn trigonometric identities, how trigonometric identities are derived. So we have a right angle triangle here, triangle ABC, wherein angle B is 90 degree. We are supposed to find the trigonometric ratios of angle C. So with respect to angle C, we have named the sides as adjacent side. That means, as you can see, BC is adjacent side to angle C and AB is opposite side to angle C, because the ratios will be for angle C. Let's begin. So first we will write the Pythagorean formula. AC square, that means hypotenuse square, is equals to AB square plus BC square. That means the sum of the squares of the remaining two sides. Let's name it as number 1. Now there are total 3 main identities that we are going to learn in this class, in this chapter. 3 trigonometric identities, and all the 3 identities will be derived with the help of Pythagorean formula. Only the difference is every time we will divide each term with square of one of the sides. Like for example, this time we are dividing each term of this formula by AC square. Next time we will be dividing by AB square, and in the next identity we will be dividing it by BC square. What we get? We got AC square by AC square is equals to AB square by AC square plus BC square by AC square. So I can write it as AC by AC whole square, and here AB by AC whole square plus BC by AC whole square. The reason writing behind in this way, because if you observe, this is a trigonometric ratio. AB by AC with respect to angle C, what is AB? Opposite. AC is hypotenuse. So what is opposite divided by hypotenuse? It is so, sine. So this is sine theta, or say sine C, and BC by AC, that means adjacent by hypotenuse, that will be cos theta or cos C. So AC by AC will be 1, 1 square is equals to 1. So here it will become like this, 1 is equals to sine C whole square plus cos C whole square. So I can write it as sine square C plus cos square C is equals to 1. That is our identity number 1. You can write sine square theta plus cos square theta is equals to 1 as well. Now, one important thing that we need to keep in mind about this identity is true for any angle from 0 to 90 degree. That means the angle can be 0 or greater than or 90 and less than. So from 0 to 90, if you substitute the value 0, for example, sine square 0 plus cos square 0. You know, sine 0 is 0 and cos 0 is 1. This we will learn in the next part of the chapter, as I told you, because therein you will learn the trigonometric ratios of angle 0, 90, 45, etc. Fine. So sine 0 is 0 and cos 0 is 1. So here it will be 1 plus 0 plus 1. So you got 1 is equals to right hand side. And 90 degree. If I substitute sine square 90 plus cos square 90. So here sine 90 is 1 and cos 90 is 0. So again 1 plus 0 you will get 1. So any value if you substitute of angle C or say angle theta between 0 to 90 or from 0 to 90, you will get 1. Let's see the next identity. Again I will write the same formula, Pythagoras formula. Now here I will be dividing each term by BC square. I get AC square by BC square is equals to AB square by BC square plus BC square by BC square. Again, I can write it like this. As I told you, the reason behind writing is to make them in the form of trigonometric ratios. Now, AC by BC whole square, AB by BC whole square plus BC by BC whole square. Now, this will become 1. Now, what is AC by BC? AC means hypotenuse by adjacent. If adjacent by hypotenuse was cos, so this is 1 by cos, that means sec. And AB by BC means opposite upon adjacent. So, opposite upon adjacent gives you tangent, that means tan theta or say tan C. Now, it is sec C whole square is equals to tan C whole square plus 1. Or you can write like sec square C is equals to tan square C plus 1, or sec square theta is equals to tan square theta plus 1. So, this is our identity number 2. Now, this identity is true for the angles, angle C or theta, that should be from 0 to below 90. That means the angle should be either 0 or more than 0 degrees, but less than 90 degrees. Why? Because see, it is 1 by cos. Sec means what? 1 by cos. And cos 90 is 0. And here it is 10. 10 means sin by cos. Again here also cos 90 if you substitute means 0. So, this will be 1 by 0 and sin 90 is 1. So, 1 by 0. And 1 by 0 has no defined value. It is undefined term because whenever you are dividing something by 0, it is undefined. So, that way this identity is not true with 90 degree. So, that is why we will write that identity sec square theta is equals to tan square theta plus 1 is true only for the angles 0 or more than 0 but less than 90. Let us see the next identity and the third identity, and it is last identity for this chapter. It is again same, we are writing the Pythagoras formula, AC square is equals to AB square plus BC square, number 1. Now, this time we are dividing this 1 by AB square. We will get AC square by AB square is equals to AB square by AB square plus BC square by AB square. That means I can write like this: AC by AB whole square is equals to AB by AB whole square, BC by AB whole square. Again this will be 1, AB by AB will be 1. Now, AC by AB means hypotenuse divided by opposite. If opposite by hypotenuse was sine, so this will be 1 by sine. 1 by sine is nothing but cosec, right? And BC by AB, BC means adjacent by opposite. So, it will be cot because opposite by adjacent was tan. So, this will be cot. So, the identity is cosec C whole square is equals to 1 plus cot C whole square. That means I can write cosec square C is equals to 1 plus cot square C. This is our identity number 3, or you can say cosec square theta is equals to 1 plus cot square theta. Now, this identity is true for the angle C or say theta, that is more than 0 degree and either less than or equal to 90 degree. Here you can't substitute 0 because it is not true for 0 degree. It is cosec is what? 1 by sine, and sine 0 is 0. So, again 1 by 0 undefined term. Cot is again cos upon sine. So, again 1 by 0 because cos 0 is 1 and sine 0 is 0. So, 1 by 0 undefined term. So, this identity is not true for 0 degree, but yes, more than 0 and equal to or less than 90 degree. Clear? So, these are the 3 identities. Now, let us see how to memorize them or how to keep them in mind. So, just to remember the identities, first let us see first identity is sin square theta plus cos square theta is equals to 1, or sin square C as I took in this triangle angle C. So, sin square C plus cos square C is equals to 1, identity number 1. Now, this is our second number identity, sec square C is equals to tan square C plus 1, and the third one is cosec square C, that means cosec square theta is equals to 1 plus cot square C, that means 1 plus cot square theta. Since we have 6 trigonometric ratios as you can see here, sin theta, cos theta, tan, cot, tan, cosec and sec. So, if you combine these two See, sine and cos is your first identity. Sum of the squares of sine and cos give you 1. So, and if you want to find sine square, simply take this cos square this side. So, that means sine square theta or c is equals to 1 minus cos square theta. Similarly, if you need to find cos square, you need to take sine square that side, so is equals to 1 minus sine square theta or c. Right. Now, sine and cos makes one identity. Now, if you notice, tan is what? Sine by cos. And cot is what? Cos by sine. Similarly, sec is 1 by cos and cosec is 1 by sine theta, right. In this second identity, I have sec and tan. See the similarity. They have cos in the denominator. So, this also is the way to remember second identity, like with the denominator having same cos, you are taking them together. If you need to find say tan square, so what you will do, simply bring this one here. So, it will be sec square theta minus 1 is equals to tan square theta. Or if you bring tan square here, so it will be difference of both the ratios will give you 1. Sec square theta minus tan square theta is equals to 1. Clear? Now, what is remaining? Cot and cosec. Again, same similarity. They have sine in the denominator. So, here also cosec square theta or say c here is equals to 1 plus cot square. So, if you need to bring cot square here, so difference of the squares of the ratios, trigonometric ratios will give you 1. Or if you bring 1 this side, you will get cot square. So, cot square is equals to cosec square minus 1. The other third way to remember this identity is they both have C letter. So, there are so many ways to memorize, to remember the identities, but the only thing is you have to remember all the 3 identities. Using these identities, you can solve many questions. I hope the trigonometric identities are clear to you now. Thank you for watching.